We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Get my feet out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 124 of the Space Rocket History Podcast. And now, Apollo, Astronaut Selection and Training, Part 2. Recall from last week's episode, I covered the first two groups of astronauts selected and some of their training. Today, we will continue the topic with Group 3. As the Apollo program came into clear focus in 1962, MSC officials saw that they needed still more astronauts. At the end of the year, projected manned space flights included 4 development flights for the Saturn I, 4 of the Saturn 1B, and 1 of the Saturn V, starting in late 1964 and flying at 3-month intervals until mid-1967. The 16 astronauts in training would not be enough to staff the 10 Gemini missions, plus the 9 scheduled for Apollo. So, in April 1963, MSC announced its intention to recruit a third class of trainees. On June 18th, the Houston Center issued its formal call for applications with the third group. The requirement for flight experience was relaxed still further. First, 1,000 hours of jet time could be substituted for test pilot certification. Second, the selection board might consider advanced degrees in engineering or science as offsetting some lack of flight experience. Third, industry, professional organizations, and the armed services were asked to recommend candidates. And fourth, Manned Spaceflight Center Chief Brainerd Holmes, acknowledging the Space Science Board's Iowa Summer Study recommendations, told Congress that scientific qualifications would be taken into account in selecting this group. Of the 271 applicants responding, 30 were selected for final screening. Of the 30, 14 were selected. On October 18, 1963, MSC announced the names of the Group 3 astronaut trainees: David Scott, Eugene Cernan, Michael Collins, Edwin Buzz Aldrin, Richard Gordon, Roger Chaffee, Don Isley, Walter Cunningham, Russell Swigert, William Anders, Charles Bassett, Theodore Freeman, Clifton Williams, and Alan Bean. Once again, military officers outnumbered civilians. There were 12 military officers and only 2 civilians. At the end of 1963, the total astronaut corps comprised 26 military pilots and 4 civilians, all trained in military service. 8 of the 14 had master's degrees, and 1 held a doctorate in astronautics. The 2 civilians were scientists actively engaged in research. Most of the military officers held engineering degrees. In spite of MSC's obvious preference for pilots, the scientific community raised no outcry about the lack of scientists in the astronaut program. However, science proponents publicly reproved the agency late in the year for not recruiting geologists to explore the moon. When Group 3 reported to Houston in January 1964, Slayton had 29 pilots to look after, including 5 Mercury veterans. The first 4 men who would walk on the moon were in training, but at the time all attention focused on Gemini, whose first manned launch was scheduled for November of 1964. Classroom work began in February with a new basic science program, a 20-week series of lectures, briefings, and field trips strongly oriented toward Gemini, but also including substantial chunks of time devoted to geology, which was entirely an Apollo concern. The veterans of the previous year's training skipped parts of this course to spend time in the Gemini simulators, but the geology sessions were required for everyone. Geologists from MSc and from the Geological Survey guided them through the equivalent of a 1-semester college course in landforms and land-forming geologic processes, materials and their origin, and topographic and geographic mapping. Lectures and laboratory work were supplemented by field trips to study the Grand Canyon, the Big Bend area of West Texas, and the volcano fields near Flagstaff, Arizona, and Cimarron, New Mexico. No one expected the astronauts to become fully qualified field geologists as a result of this training, but they could at least learn to interpret what they would see on the moon in terms of its probable geologic history and to recognize important geological specimens if they found any. On the later field trips, the geologist instructors began simulating lunar exploration by sending their pupils into an area with a radio transmitter and instructions to note the geologic features they could see, describe what they considered important, and collect representative samples of rocks and surface material. Their commentary was recorded, and the exercise was completed with a detailed critique of their performance. Geology was a new field for most of the engineer astronauts, rather unlike anything in their experience. What impressed most of them was the large amount of specialized terminology they had to learn, new words having little relation to their accustomed vocabulary. Instructors found them willing enough students for the most part, but highly variable in their response to the course. Some seemed to be born observers and quickly developed the knack of picking out the distinguishing geologic features of an area and describing them in a geologist's terms. Others had more difficulty acquiring the field geologist's eye. Apart from the problem of adjusting to a new discipline with a novel point of view, the astronauts faced the question of how heavily their performance in geology would count when the time came to select flight crews. Seniority and flying experience seemed to be the prime importance in determining who got the assignments for Apollo flights, and it was important to get picked as early as possible for a Gemini crew. Well aware that no one could completely master every aspect of training, the astronauts sought to shine in those aspects that were most likely to attract Deke Slayton's attention. For the short-term future at least, geology seemed fairly far down the priority list. Now let's consider Gemini flight operations and how they affected astronaut selection and training for Apollo. After a problem-filled 1963, Project Gemini looked toward better things in 1964. The first flight test of the spacecraft and its Titan II launch vehicle went off on April 11th, raising hopes of a manned flight before year's end. 2 days later, the Manned Spacecraft Center announced the names of the first crews for the 2-man Earth orbital missions. As might have been expected, the commander of the first Gemini mission was one of the original 7, Gus Grissom, who had ridden the second orbital Mercury flight in 1961. Paired with Grissom was one of the second astronaut groups, John Young. Their backup crew likewise had a representative from each of the first two astronaut classes, Wally Schirra, pilot on Mercury Atlas 8, and Thomas Stafford. A week after the announcement, the 4 Gemini crewmen headed into full mission-specific training schedule. At the spacecraft builders plant in St. Louis, and at Mission Control in Houston, and at the Cape in Florida, the astronauts put in long hours learning the design and function of the spacecraft systems, following the assembly and testing of their spacecraft, attending briefings on program and mission objectives, and practicing such tasks as getting out of a floating spacecraft. Simulators duplicated as closely as possible most of the conditions of launch, orbital flight, and recovery, except for weightlessness, of course. And in these simulators, the crews practiced normal operations as well as all the likely malfunctions their training officers could think of. Occasional trips to the Navy's man-rated centrifuge in Johnsonville, Pennsylvania, gave them practice in enduring the acceleration forces of launch and re-entry. Training stretched from a planned 7 months to 11 months when their flight was delayed by problems with the second unmanned test. And by the time their flight was ready for launch on March 23, 1965, the crews would have been hard to surprise with anything that might come up. When crews were named on July 27, 1964 for the second Gemini mission, Slayton broke the pattern of designating an orbital veteran as commander. He chose 4 inexperienced men for Gemini 4, even though 1 Mercury astronaut had not been assigned. Jim McDivitt and Ed White were named commander and pilot of the prime crew, backed up by Frank Borman and Jim Lovell, all members of the second astronaut group. Of the original 7, Group 1, Glenn had resigned, Carpenter was working in Project C-Lab, and Slayton was medically disqualified. At the press conference naming the Gemini 3 crews, it was also announced that Alan Shepard was suffering from a middle ear inflammation that grounded him as well. Later that year, Shepard took over from Slayton as chief of the astronaut office. Only Gordon Cooper remained unassigned at this time. Flight experience seemed clearly to be a factor in Slayton's choice of crews, but it was just as clearly not the only factor. Gordon Cooper, pilot on the 34-hour 22-orbit Mercury 9 mission, was not assigned until the Gemini 5 crew was named in February 1965. His pilot was Charles Pete Conrad of the second group. Their backups, both from the second group, were Neil Armstrong and Elliot C. After Grissom and Young completed Gemini 3, Slayton announced that their backup crew, Schirra and Stafford, would be the prime crew for Gemini 6, backed up by Grissom and Young. To trainees eagerly seeking some clue to their prospects for flight assignment, this signaled that appointment to a backup crew was the key to flying a mission. The system Slayton followed, as long as circumstances permitted, was to promote each backup crew to prime crew of the next available mission after their own prime crew had flown. Each flight had different objectives, requiring different training, and the prime and the backup crews had to train as a team to perform more efficiently. Almost to a man, the astronauts professed being in the dark as to exactly how Slayton chose crew members for their first assignment. But that did not matter once they perceived that when they were named to a backup crew, they were at last in line for a flight assignment. Okay, how did Group 3 fare with the Apollo lunar program? I'm going to answer that question, but I'm only going to include their role in the Apollo lunar program, nothing before or after. No spoilers for any flights after the Apollo lunar program. First, we have Edwin Buzz Aldrin. He was the Apollo 11 lunar module pilot, which of course was the first manned lunar landing, and he became the second man to walk on the moon. William Anders was on Apollo 8 as the lunar module pilot, and this was the first manned circumlunar flight. Alan Bean was on Apollo 12 as the lunar module pilot, the second manned lunar landing, and Bean became the fourth man to walk on the moon. Gene Cernan was on Apollo 10 as the lunar module pilot, which was the dress rehearsal for Apollo 11. Gene also commanded Apollo 17, the final manned lunar mission and final manned lunar landing. Cernan is the last person to walk on the moon. Michael Collins was on Apollo 11 as the command module pilot. Walter Cunningham was on Apollo 7 as the lunar module pilot. Don Isley was on Apollo 7 as the command module pilot. Richard Gordon was on Apollo 12 as the command module pilot. Russell L. Swigert was on Apollo 9 as the lunar module pilot. David Scott was on Apollo 9 as the command module pilot and Apollo 15 as the commander. He was the first to use the lunar rover, and Scott became the seventh person to walk on the moon. Now, the final four of Group 2 were unfortunately fatalities. Clifton Williams was killed in a plane crash. Theodore Freeman died in a T-38 plane crash in 1964. Roger Chaffee died in the Apollo 1 fire with Gus and Ed White. And Charles Bassett died in a T-38 plane crash with Elliot C. Now let's move on to Group 4. NASA headquarters hoped to mollify some of the scientific grumblers and to strengthen its ties with the scientific community by emphasizing Apollo's potential contribution to science, not only from the instruments that would send back information from the moon, but from the men who would fly them there. Surprisingly, some of the drive to enlist these scientist astronauts came from engineering-oriented Houston. Robert Voss, human factors assistant to Gilruth and a key figure in setting up procedures for selecting Mercury pilots, conferred with NASA Director of Space Sciences Homer Newell in Washington in 1963 about Houston's view on scientists for the space program. Voss later met with Eugene Shoemaker of Newell's office, Joseph Shea, and George Lowe to discuss the most appropriate specialties. With an eye to lunar surface, long duration, and Earth orbital activities, the quartet agreed that the disciplines needed were geology, geophysics, medicine, and physiology. At the September 1963 meeting, Voss emphasized that Houston wanted qualified pilots, but Shea saw no need for any previous flight experience. Why not take this opportunity to introduce methods for selecting and training non-pilots, he thought. In the end, the consensus was that candidates with flying backgrounds would be given preference, but that applicants from otherwise qualified men who lacked this training would be accepted. And the National Academy of Sciences should be asked to help recruit and select scientists for the program. Administrator Webb approved the recommendation. During this time, George Miller was soliciting Congress to continue using Apollo's rockets, spacecraft, and launch facilities to conduct scientific and technological investigations on the moon and in space, to produce a return on the nation's investment in manned space flight. Miller's proposals were criticized as unimaginative and not conducive to the advancement of space technology, but none of NASA's top managers was willing to advocate bolder programs under the budgetary restraints that were becoming apparent in 1964. For any serious scientific work, the crews in the spacecraft would have to include some scientists trained as astronauts rather than astronauts trained as scientific observers. MSC officials and representatives of the National Academy of Sciences met in February of 1964 to draft a plan for recruitment and selection of scientist astronauts. At the meeting, Harry Hess of the Academy agreed to have his Space Science Board define appropriate scientific qualifications, and Houston would be responsible for the physical criteria and age requirements. On April 16th, Homer Newell formally asked Harry Hess to draw up a statement of the scientific qualifications for a scientific astronaut. Hess established an ad hoc committee which submitted its report to Newell in July. In October, NASA announced that it was looking for astronauts with scientific training. For the first time, the selection criteria did not include a requirement for test pilot proficiency. Selectees who were not qualified pilots would be assigned to the Air Force for a year of flight training. The primary scientific requirement was a doctorate in medicine, engineering, or one of the natural sciences. Any doubt that scientists were interested in spaceflight was dispelled by the response. More than 1,000 applications were received by December. 400 of these were forwarded to Hess's board in February 1965 for academic ranking. An ad hoc committee of the Space Science Board rigorously scrutinized the 400 of those who passed NASA's preliminary screening, finally sending only 16 names to NASA for final evaluation. MSC had hoped for a larger group to choose from. Deke Slayton's selection board had much less information on the applicant's physical condition and psychological makeup than they had for military applicants, and the choices were consequently harder to make. The Space Science Board, however, was evidently determined to pick only the most promising scientists. Shoemaker later recalled that the committee had been disappointed in the overall quality of the applications that came in. Not many of the scientists who applied came up to the rather high standards they set. Whatever the reasons for this, NASA was able to pick only 6 scientist astronauts instead of 10 or more as NASA had originally planned. On June 27, 1965, NASA announced the names of its first scientist astronaut candidates. 2 physicians, Dwayne M. Graveline and Joseph P. Kerwin, and 4 PhD scientists, F. Curtis Mitchell, Edward G. Gibson, Owen K. Garriott, and Harrison H. Smith. Kerwin was a flight surgeon stationed at Cecil Naval Air Station in Florida. Graveline, a former Air Force flight surgeon, was working in the medical program at MSC. Gibson and Garrett were both engineers engaged in research in solar and atmospheric physics. Gibson worked at the Applied Research Laboratories of Philco's Aeronautics Division in San Diego, California, and Garrett was Associate Professor of Physics at Stanford University. Mitchell was an Assistant Professor of Physics at Rice University in Houston, conducting research in the interaction of the solar wind with the Earth's atmosphere. Smith, the lone geologist in the group, was working with Eugene Shoemaker at the Geological Survey Astrogeology branch. The only qualified pilots in the group were Mitchell, a former Air Force pilot, and Kerwin, a naval aviator. The other 4 were sent to Williams Air Force Base in Arizona to begin 55 weeks of flight training. Within a few weeks, however, Graveline resigned from the program, citing personal reasons. Only Harrison Smith made it on an Apollo lunar mission. He was lunar module pilot on Apollo 17. The remaining members of Group 4 had other significant accomplishments that will be covered in later episodes. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.